Have you ever wondered if we could make other planets more like Earth? Imagine stepping onto a planet millions of miles away from home, taking off your helmet and breathing in the fresh air. This might seem like science fiction, but it's a concept that scientists and researchers have been exploring for decades. It's called terraforming, a process through which we could potentially modify the conditions on other planets to make them more like our own. But the question is, could we extend this process to other planets in our solar system and even beyond? What would it take to turn an inhospitable, barren world into a thriving, lush environment where humans could live and thrive? Today we're going to delve into this fascinating topic, using Mars, our next-door neighbour in the cosmic sense, as a case study. So, buckle up for a journey beyond our planet, into the realm of what could be, as we explore the exciting world of terraforming. To understand terraforming, we first need to know what it entails. At its core, terraforming is an ambitious idea that deals with modifying the environment of a planet, moon, or other celestial body to make it habitable for human life. This process involves altering the atmosphere, temperature, surface topography, and ecology to closely mimic those of Earth. The idea of terraforming is not new. It has been a staple of science fiction for decades, inspiring countless novels, movies, and games. However, in recent years, it has evolved from a mere concept into a serious field of study. Scientists and researchers around the globe are now investigating the feasibility of transforming other planets into livable spaces for humans. The process of terraforming is complex and multifaceted. It involves a multitude of scientific disciplines, from astronomy and geology to biology and engineering. Key aspects include creating an atmosphere that can retain heat and protect against solar radiation, establishing a stable climate, and fostering the growth of life-sustaining ecosystems. Currently, our understanding of terraforming is largely theoretical, based on our knowledge of Earth's life-supporting systems and the conditions found on other planets. We haven't yet developed the technology or resources to enact large-scale planetary transformation. But this doesn't mean it's impossible. With the rapid pace of technological advancement, the prospect of terraforming could become a reality within this century or the next. The concept of terraforming presents both enormous challenges and incredible opportunities. It has the potential to expand the boundaries of human civilization, opening up new realms for exploration, colonization, and resource utilization. However, it also poses significant ethical and environmental questions that we must carefully consider. With this understanding, we can now look at Mars, our nearest neighbor and the most likely candidate for terraforming. Mars, often referred to as the Red Planet, presents both opportunities and challenges for terraforming. With its thin atmosphere, cold temperatures, and lack of liquid water, it's a harsh environment, to say the least. However, it's also our nearest neighbor, and has been the subject of numerous space missions, rovers, and landers, all aiming to uncover its secrets and potential for human habitation. Scientists have proposed various methods to make Mars more Earth-like, from releasing greenhouse gases to melt the polar ice caps, to crashing comets into the planet to increase its atmospheric pressure and temperature. The goal? To create an environment where humans could walk outside without a spacesuit, breathe the air, and maybe even grow crops. But terraforming Mars isn't a walk in the park. First, there's the issue of its thin atmosphere, which is about 100 times less dense than Earth's. This makes it a poor shield against harmful radiation from the sun and cosmic rays. Building up a thicker atmosphere could take centuries, or even millennia. Then there's the problem of Mars's lack of a magnetic field. On Earth, our magnetic field protects us from solar winds, streams of charged particles from the sun. Without a similar shield, any atmosphere we build on Mars could be slowly stripped away by these solar winds. And let's not forget about water. While Mars does have ice caps made of water and carbon dioxide, we'd need to find a way to unlock this frozen resource and make it available for human use. Despite these challenges, Mars remains our best shot at terraforming. It's close. It's relatively similar to Earth in terms of day length and seasons, and we already have a wealth of information about it. Mars offers a valuable case study, but what about other planets? Could we apply what we learn on Mars to terraform Venus, Titan, or even exoplanets in distant star systems? The possibilities are as infinite as the universe itself. Beyond Mars, there are other celestial bodies that could potentially be candidates for terraforming. The universe is teeming with planets and moons, each with their unique characteristics and possibilities. Let's delve into a few of them. First up is Venus, our closest planetary neighbour. Often dubbed as Earth's evil twin, Venus is about the same size as our home planet, but is shrouded in a thick, toxic atmosphere, with surface temperatures hot enough to melt lead. But if we could somehow cool it down and alter its atmosphere, it might just be a place where humans could live. Next, we have Titan, Saturn's largest moon, and the only celestial body other than Earth known to have liquid on its surface. But it's not water. It's methane and ethane. Titan's atmosphere is primarily nitrogen, like Earth's, but it's extremely cold, with temperatures averaging around negative 290 degrees Fahrenheit. If we could warm it up and ensure there's enough oxygen, Titan might be a candidate for human habitation. Then, there are exoplanets in habitable zones or Goldilocks zones, where conditions might be just right for life as we know it. These planets are neither too close nor too far from their stars, meaning they might have liquid water on their surfaces. One such exoplanet is Proxima Centauri b, our closest known exoplanet, located in the Alpha Centauri star system. The challenges of reaching and terraforming an exoplanet are immense, but the rewards could be extraordinary. Each potential candidate presents its own unique set of challenges and opportunities. For Venus, it's about cooling down a hot, dense world. For Titan, it's about warming up a frigid moon and adding oxygen. And for exoplanets, it's about reaching them in the first place. But with every challenge comes the opportunity for innovation and discovery. And who knows what we might achieve if we dare to dream big enough. Terraforming would require a variety of methods and technologies. What we're talking about here isn't a one-size-fits-all approach. Each planet or moon presents its own unique challenges, requiring tailored solutions. Let's start with greenhouse gases. These are gases that trap heat in a planet's atmosphere, increasing its temperature. On Mars, for instance, we might consider introducing greenhouse gases to warm up the planet's surface, making it more hospitable for human life. This could be achieved by releasing gases stored in the planet's soil or by importing them from Earth. Creating artificial atmospheres is another potential approach. This involves generating a breathable environment from scratch. It could be achieved through a process called electrolysis, where water is split into its component parts, oxygen and hydrogen. The oxygen could then be released into the atmosphere, while the hydrogen is vented out into space. But it's not just about the air we breathe. We'd also need to consider the planet's soil. Is it capable of supporting plant life? If not, we might need to import Earth-like soil, or find ways to enrich the native soil with necessary nutrients. This could be achieved through a process known as ecopoiesis, which involves introducing microorganisms to the soil to kickstart the process of creating a biosphere. And then there's the matter of water. Life as we know it requires water. If a planet doesn't have sufficient water, we'd need to find a way to introduce it. This could involve redirecting comets to crash into the planet, delivering vast quantities of water ice. Of course, these methods are all highly theoretical and would require technological advancements beyond our current capabilities. And even if we could achieve them, it would likely take centuries, if not millennia, for the terraforming process to be completed. The methods we've discussed are just the tip of the iceberg. As our understanding of the universe expands and our technology advances, who knows what other tools we might discover for transforming alien worlds into new homes for humanity. While the potential benefits of terraforming are immense, it's not without its risks and challenges. As we venture into the realm of transforming alien landscapes into human habitats, we need to confront a multitude of ethical, environmental, and potential unintended consequences that come with it. Firstly, let's talk about the ethical considerations. We must ask ourselves, do we have the right to alter another planet's environment to suit our needs? This is a question that divides the scientific community and the public alike. Some argue that it's our duty as an intelligent species to expand and survive, while others believe that we should respect the natural state of other planets and prioritize fixing the environmental issues on our own planet. Next, there's the environmental impact. Terraforming is a process that would drastically change the entire ecosystem of a planet. We could be introducing foreign elements that may have unpredictable effects on the planet's natural state. For instance, introducing greenhouse gases to warm up a planet might trigger a runaway greenhouse effect, making the planet uninhabitable. there's also the risk of potential unintended consequences. Despite our best intentions and careful planning, there's always the possibility that things could go wrong. An error in the terraforming process could lead to disastrous results. We could inadvertently create a hostile environment that's even more inhospitable than before we started. Moreover, there are also technological challenges. The technologies needed to undertake such a vast project are currently beyond our reach. We're still in the early stages of understanding how to manipulate an entire planet's environment. It would require advances in multiple fields of science and engineering, and a considerable amount of resources and time. Lastly, there's the challenge of distance. The planets and moons we might want to terraform are incredibly far away. Even if we overcome all the other challenges, getting there and setting up the necessary infrastructure would be a colossal challenge. These challenges remind us that terraforming is not a simple task. It's a complex, long-term project that will require careful consideration, meticulous planning, and the collective effort of the global scientific community. Despite the challenges, the future of terraforming holds exciting possibilities. Imagine a universe where humans have not just one, but multiple homes scattered across the cosmos. This is the promise of terraforming, the ability to transform inhospitable worlds into livable environments for humanity. Terraforming could offer us a solution to some of our most pressing problems. As Earth's resources dwindle and our population grows, we're forced to look to the stars for answers. Successfully terraforming a planet could provide us with a whole new world of resources and space to grow. But the benefits extend beyond the practical. The scientific discoveries that would come from such an endeavor are almost unimaginable. We could learn so much about the universe, about life, and about ourselves. However, this dream isn't one we can realize alone. The scale of terraforming projects is so vast that it would likely require a global or even interstellar effort. Countries around the world would need to pool their resources, their knowledge, and their manpower. It would be a testament to what humanity can achieve when we work together. Of course, successfully terraforming a planet would open the door to human colonization and expansion. It's an exciting thought. Humans living on Mars, Venus, or even an exoplanet light years away. We could become a multi-planetary species, but this isn't just about survival or expansion. It's about exploration and discovery. It's about pushing the boundaries of what's possible. It's about our insatiable curiosity and our enduring spirit of adventure. There's a long road ahead, filled with technological advancements, scientific discoveries, and ethical debates. But the potential rewards are worth the journey. The future of terraforming is full of intrigue, and it's a journey we're just beginning. Terraforming presents us with both exciting opportunities and formidable challenges. As we've journeyed through this cosmic conversation, we've delved into the fascinating concept of transforming inhospitable celestial bodies into livable environments for humanity. We began by understanding what terraforming entails, unraveling the principles and processes that could turn a barren planet into a potential second home. The red Martian landscape served as our case study, its rocky terrain and thin atmosphere offering a glimpse into the challenges we face in this grand endeavor. From Mars, we ventured further into the cosmos, considering other planetary candidates ripe for terraforming. Each presented its unique set of circumstances. Venus with its thick, hot atmosphere, Titan, Saturn's moon, with its hydrocarbon lakes, and the exoplanets nestled within habitable zones far beyond our solar system. We explored various methods and technologies that could be employed for terraforming, from releasing greenhouse gases to creating artificial atmospheres. The potential benefits of such endeavors are tantalizing. Human colonization, resource utilization, scientific research, and perhaps even the survival of our species. Yet we also acknowledge the daunting challenges and risks. Terraforming is not merely a scientific and technological challenge, but also an ethical one. We considered the environmental impacts, potential unintended consequences, and the critical role of international collaboration in such large-scale projects. Alongside the scientific and technological aspects, we pondered the role of public perception and support. The success of terraforming projects may hinge on our ability to educate, to raise awareness, and to foster a shared vision of a future where humans might call multiple planets home. Terraforming is a testament to our unyielding curiosity and our capacity to dream beyond our earthly confines. It's a grand vision that could shape the future of humanity, a future that might not be confined to the blue and green orb we call home. As we dream of making other worlds more like home, we invite you to dream with us, share your thoughts, and remember to like, subscribe, and share this video.